Thank you very much. My name is Dr. Victor Cheng. I work for Shenzhen Liverpool University. So my background is data science for multidiscipline. I'm the conference chair of IoT, BDS, and complexity. So my talk today is on enterprise information system to realize and understand more about the world. The topic sounds big, but then before we are going to introduce further, let me just introduce about the overview. I'm going to start with the modern enterprise information system. EIS, because when the technology has been moved on, then we use different type of technology and technique that include a cloud, Internet of Things, big data, and the overview with architecture. And then I'm going to focus more on weather, research and computing, and finance and economic research, and other services that can be enabled by EIS, as well as the summary of the research contribution, discussion, and conclusion. So then, there are a lot of problems in the world. We know that we suffer from typhoon, flood, extreme weathers, pollutions, and then even poverty, earthquakes, extreme weather, uncertain period of time, and then drought. And of course, economic and finance problems that leads to job losses and strikes. So the world is having a lot of problems. As a scientist, what should we do? We should use other technology and technique to help us to understand. These are the big issues. But then, what are our approaches? Now, we are at the age of facing the new technology and techniques. So, what can we do? First of all, the use of Internet of Things with a lot of sensors to collect data so that we then realize what has been happening in the world. What we can then realize what has been happening here and then we have the most up-to-date. Then we can then connect to each other, collect data, analyze data, and then we can understand the implications. And data have all types of forms, and then from different types of discipline, in text, in images, video, and so on. Then we need something to realize the deep analysis, because we need to understand, after collecting so much data, what are the lessons learned? How can we know the better future? How can we help us to gain for the most benefit of it? And then, at the same time, we don't want to spend too much cost. We don't want to spend millions, billions, like keep burning money. We need to then extract the knowledge and then combine other fields. Because now, while we are at a junction of doing different disciplines, we need to learn a little bit of statistics, machine learning, data mining, big data, and predictive analytics. In this world, in the past, we can have one job that lasts for a long time, but now we will have the opportunity for multidiscipline, because once you acquire the skill, then we can apply the same principle in healthcare, education, smart city, energy, and transportation. So I have other keynotes on other disciplines. So then, in this world, there are a lot of problems. But now, as scientists, what we can do is that we can only focus on two at most and do well in this. One is on the weathers, because we know that the world has been at the stage having the global warming. As a result, the extreme weathers are not just outliers, but then it's moving in a direction of becoming a norm. Then the next thing is economic and finance, because after 2008 and 2009 financial crisis, a lot of European countries are still having problems. So then we will then combine all different resources, just like we get all different people from different parts of the world. The collection of the wisdom will be able to let us to solve the problems ahead. So then it doesn't matter what you do with GIS, medical, transport, weathers, but then the most important thing is, first of all, we need to collect data. Secondly, we need to extract and understand. Then we have to process and analyze. And then we have to visualize. For instance, how about the most expensive area in London? Then this is in blue color. Then those areas, then you can also track on the human activities, housing prices, quality of air. So then analytics might be an answer. But then behind analytics, there are things that with artificial intelligence, algorithms, machine learning, and pattern studies, so that it helps us to have a better understanding. Then at the same time, we help to reduce Spark and data lake. The technology will help us to enable us to solve the problem. But then, of course, we need to think about the security, privacy, and trust. So then, before we get into further, let us just look at the architecture, because architecture is important. Whatever we do, there's also security, because when you collect data, you may collect data with a personal identity or personal data. Then at the same time, we should have a trust platform with encryption, access control, and with a top-down overview, cloud computing, communication, identification, followed by distributed system and distributed intelligence, because it's the smart data that makes sense. And then they will also connect to the data representation, so that it will help us to analyze what are the meanings behind. And then we have the network protocols with different networks, so that we can then understand, we can combine with other disciplines such as energy harvesting and even the architecture, so that we can then make it a better architecture. The second type of architecture follows with the things, Internet of Things, that collect the data from, let's say, when you step outside your home, your movement can be tracked by the sensors installed at different parts of the city. If we are doing the smart city, and then when we have all different type of data, we have to store them with different format, and then we make sense of it. At the same time, this is a loop. We need something with a simplified analytics, because for users' point of view, we do not need to know what are the complications behind. Then another way of doing it, because there are different type of data. How about, can we manage the transportation data? And then you follow with logistics, and then all the way down, healthcare data, we need to track the patients, and we have to identify the right patient, and then we collect, and of course we have to keep up to date. And then smart environment that we have to combine with different offices, plants, and buildings, and then personal and social data. We have to understand how people interact with each other, and then what are the implications behind, and also the future aspect of it. So we can then make a better prediction based on what we have collected. So then, as I have mentioned, there are two areas that I'm going to focus. So one of them is weather analysis and visualization. So before I'm going to get into details, let us just look at the output. It's just like, imagine you know nothing about what I do. Then visualization might be the key. Why? Imagine this is the map of India. Like, let's say I'm a tourist. Let's say that is before this date. So then what we can do is that this is the map of India. And this is the temperature from the lowest, the minus 9 all the way to plus 30 or so. So that just within 1 second, you know the temperature. So let's say if I'm going to Chennai here, so the temperature is saying it's about 29 degrees Celsius. Just 1 second. And we are talking about the entire India. We are not talking about, New Delhi, Chennai, so on. Then internet search will you have to check one by one, and then after that, you spend minutes to check the entire India. So what we can do is that we can combine different technology, and then we can compare with the same day, 17th of January and 18th of January, and then same time with different day. And you notice that there is a much higher temperature of more than 3 to 5 degrees Celsius. So that everything you can see is that with a cross comparison. And how about the same day with a different time scale? Let's say I have 5 p.m. versus 7:30 p.m. So with a 2.5 hours difference, and you can see that the temperature here, let's say Chennai, there's about 30 degrees Celsius, and then here is about 27 degrees Celsius. It gives you just 1 second, you know the difference, and that is the powerfulness of the weather data visualization. And then how about Malaysia? Malaysia is a country that the Dino research is from originally. Then Malaysia has the east and the west. So then you can compare, different part of Malaysia with different type of color code. Each color code corresponds to a different temperature. Then you can see the entire temperature of Malaysia. So then you can just with 1 or 2 seconds, you don't have to check one by one. So that is the benefit. And how about UK? I spent about 14.5 years. So this is just to show that it's done by me. It's not, like I asked my student to do it. No, everything was all done by me. So then we can make a cross comparison between January 19 and April 7. So, same country, different dates. one for the winter, one for the spring, and then you can see the differences there. Here, let's say you are in London. London is somewhere here. Then the temperature is about between 0 to 5 degrees Celsius. Then back to the spring, then let us take the temperature of London, that is roughly about 12 degrees Celsius. So then you can then make a cross comparison very easily. Then how about, this is the time in Europe, and this is a cross comparison. Let's say now I want to check 4 European countries' temperature in one go. Then I can then simultaneously then give a computation. So the computation was this is France. So in France, then you can see the temperature. Let's say Paris somewhere here. So then it's corresponding to about 5 degrees Celsius. So then similarly, if you are looking at London, so London will be corresponding to about 3 degrees Celsius. So you are looking at the entire map within just 1 second. And then similarly, I'm using the same date and time. So I'm just running all the 4 results. Then you can see that in Germany, Berlin will be getting about 3 degrees Celsius. And then Italy is relatively warm. So it gives you the immediate impression is much warmer. And then if, let's say, you are going to Italy as a tourist, then probably it's a very good idea. You don't have to check all the temperature. And probably you don't have to wear so much. And the impact is immediate. Then how about you can use the same principle to analyze Singapore. So I stay in Singapore for a long time. So that you can see the temperature here, most of the part of Singapore is about 27 degrees Celsius. And then there are also fluctuations between different types of temperature. So as a data scientist, then we also measure the outliers. So why sometimes the temperature is so high was because of bushfire in Sydney. They raised the average temperature of between 5 to 8 degrees Celsius. And similarly, we can look at the Cyprus and then the entire map of Australia. So you can see the impacts immediately. So then what are the implications? Because we have to know how big data can help us. So in terms of data science, there are 5 V's. So 5 V's will let us to use the modern techniques to save effort and money, but also concept as everything as service, because everything is all connected. And then extreme weather frequency, as mentioned, now it has on a way to move as a norm rather than being outliers. So there are different type of examples in USA. They have extreme weathers with hurricanes and flood, and then other part of USA, you don't have water. So things like that happen, then that is very important for us to measure and understand the weather science. So even in India, in flood, that's very unusual. Then if you have the opportunity, there's a live project. It's called earth.nutshellschool.net. So you can see the direction and strength of airflow live. So this is the benefit of using the data analytics. You can see everything live. So then my approach is like, yes, these are brilliant and wonderful, but it's going to cost you a lot of money. Without a team, this is impossible. But then, do we have anything that is cost effective, that enable you to do this? So I do have a single order paper towards data analysis for data, weather cloud computing. A knowledge-based system on the way to have the impact factor to become 3.8. So then we need something. So before that, as a scientist, we need to talk about the literature. So the literature, the weather computing started in 1940s. That we use, scientists use a system to build it. And then Campbell and Debo, they were very well known because they invented the term weather derivatives. So a lot of mathematics, then derivatives. Then they also study 5 US cities for 5 years. And then the other type of scientists, they have multi-billion funding. So usually what people do in the past, you must have a lot of money. Without money, you can't do science. But then they have built a very big system to analyze. And then there is another group of researchers that use the ICEIS approach. So they use principle of HEP2 algorithm. So HEP2 can be used to increase the processing. Then also other part of scientists that analyze data, including geospatial data. So geospatial data are focused on GIS, on the locations, and then in relations to the weather, so that they study the weather over a period of time, and then they then work out the pattern. So with the result, they work out with the algorithm, not the algorithm, then result. So then the other type of researcher, they use weather forecasting. So similarly, with the historical data to help you to better analyze for the future temperature. So there are other number of approaches. So similarly, there are also people using the financial derivative. They move that into weathers. So there are also people that have been using different type of thing, and they use a very expensive system to analyze it. And there are also people just do a lot of work, but then they do not do a lot of performance measurement. So performance measurement means that every time, if I'm doing this data processing and analysis, how long is it going to take, and when can I get the answers? It's not just a matter of, in the past, we are talking about days, and then it decreased to hours. But is that good enough? So then we have to build something affordable to allow us to, like there are scientists that use the 2012 data, the entire data, to forecast for the next 2 years, just to see is there any correlations and discrepancies. And then also there are other people to use formulas, so they can be very mathematical. So I am not going to go into detail. You can read everything in the paper. So forecasting is very heavily based on mathematics. So in simplified version, so we know a method with a value, with history, and of course, is that the value is being measured at the time. And then prediction means that now, let's say, now in finance, this is the price for $82. So based on the historical trend between 80 to 85. So the next prediction might be likely to fall into this range with about 70 to 90% of probability. So this is very heavily used based on the historical data to help you to analyze. So we have a few more formulas. So first of all, mean based means that you always take the average. So usually what the scientists do is that you got a lot of ranges. So what you do is you always take the averages. It's the same thing for stock market exchange. All the index values are the average value. And then, of course, you can take, between the ups and downs, you take the average. And also, at the same time, for errors, you take the ups and downs, and then you do the square root. And then, of course, there are also median method, so you do the same. So that everything, you always double check before analyzing it. So ARIMA has been very popular in derivatives. So ARIMA is very useful for prediction. So ARIMA can then allow you to do this. But then ARIMA itself is not good enough because we need an error correction technique. So error correction means that whatever you do, so ARIMA always give you about up to 10% of uncertainty. So it's like, this is your predicted value, but then there is a 10% uncertainty in there. So then, based on this 10%, then you analyze another, so it's like another 10%. So we need an error correction to do the real time. So it's like error correction will reduce the errors and uncertainty down to between 1 to 3%. So it depends on the amount of data and complexity algorithm. So if you have interest, just read the paper. Then prediction is very heavily based on this. So this is the square mean, so that everything I do, so there's a time series, so then I do a square root, and then I do this sum, and then I do it together, and then after that, I have to take the minimums and maximums, so that the mean square prediction error and the mean percentage prediction error are the ones that we look at. So these are the key inputs and for prediction. So before you do the prediction, you need to justify all the values. So if you have the opportunity to read the papers, then there will be other values. So everything you do, there must be justifiable values. So then before we do that, because, before we do any large data processing, we need to really understand what are the best approaches. So in simple form, data sources to pass to the data warehouse, and then you must make a job request. And with a job request, you then make an initialization. and then to make this platform to work again, and with a MapReduce analysis. So MapReduce has been used in several research papers. So MapReduce, in order to be better optimized, what we can do is that there's an output and then a merge. So there's a map and a merge, and then reduce. So then it's not enough, because a lot of MapReduce is based on input, output, just one. So my approach is that there are 3 workers. So imagine if there are 3 security workers to check every single processing you do. So there is also a queue system, so everything queues up. So imagine, if before you come to portal, there are lots of gates. So there are 3 major gates. So for you to do this, and everything is all being transferred, and then you are going to merge the data together. And then we then do the reduced. So at least it can then speed up the processing. But is that good enough? No. Optimization means that for MapReduce, we always have a pair called K and V. So K and V means these are the key values inside the MapReduce. So then what does this mean? It means that when you got all this output, is it good enough? The problem with a lot of MapReduce errors or extra time is that there are no additional checks. So my approach is that whatever I do, I always do additional check, and then to speed it up, it's like, is it done? Done. Then you move on next. Is it done? Done. Then so similarly, you are doing in parallel. So K-way merger for map function is an algorithm with 3 steps. So there are 3 different steps in order to make it work. So they are step 1 to write the first pair of C2 to C4, and step 2 to make that into different thing. And then step 3 to check everything works. So in order to optimize it, it's very important to check it and then push it forward and finalize it. So it's the same thing in parallel, so that everything can be largely reduced. So it's very similar to manufacturing process, that everything in order, and we have to speed it up. Then there are also other framework with input and output. So in MapReduce, I'm not going to go into details. So we get map, shuffle, reduced, and output, and a key and value are the ones which we have talked about. And therefore, we then can summarize that as a function map and function reduced. So this is the simplified version. So in other words, the reason of using NoSQL is that it can provide a better security, because with SQL, it's been around for many years. So the way to hack is very easy. It's like you just send a lot of garbages, which is called SQL injection. So you know where the port is the vulnerable thing. So what you can do is that you write a script, then send millions of garbages, and then there is more than 50 chances that the databases may be prolonged. So the best approach is that we use the NoSQL, so that now it's not that easy. So then in this example, we use the HBase. So then you can write the code to retrieve it. So if there's similar things, then you make it happen. Then at the same time, we get output with a key and null. So this is a simplified version for MapReduce. And then we have to do a lot of measurement and analysis before we do a prediction. So first of all, I use 3 cities. So one of them is Sydney. So you have collected 20 gigs of text file. So text file in simplified form. So you see this historical, and then based on historical, then I use those formula I presented. So I can then see the forecasted. They looks like that, and then these values represent the mean square error and the mean percentage error. So that the smaller the value, the better it is. So that in order to ensure that the results are accurate, the numerical value should be as low as possible. So similarly, I've done for Singapore with 20 gig, so then historical data versus the forecasted data. But although there are some discrepancies, but in general, they are very similar. And then with a very low values while you are doing all the analysis. And similarly, I then reproduce, and then I do the weather computing for the London. So with a very similar values, and they are very low, so that I replicate based on the 2 years data, then make a forecast of the next 2 years. So then the architecture looks like this, with the SQL databases, and this is administration with a user front end. And then pipeline means that we'll ensure all the requests have been done, and then we can move on to the next stage. And then we have the master and slave model, so that all the numerical result and visualization can be separate, but then they have their own ways of operation. So this is the general architecture for this. So then I have to do a lot of experiment, such as number of nodes. So if you have the opportunity to do grid computing or cloud computing, so the more the number of nodes or more CPU, then the more likely time that you are going to get a lower execution time to finish each job. So then I compare cloud and non-cloud, so that I make a fair comparison. And then I then put those 20 gigs of data. So it's relatively faster than other approaches. So it's like, because in order to make it fast, we have to know the data well. So if we know the data well, so it's not a big deal. You get a short period of time. So the execution in 3 cases all can be completed in less than 2 minutes. But then is that good enough? Probably not. Why? Because when we're dealing with weather data, we are talking about a lot of data. But then we can only do well when we only specialize. So just to replicate the success, what we do is that then I replicate it, read data just to read all the data. Then I process data. Is that I perform all the MapReduce function. And update data means that it's not when it's finished. Then we have to know it's finished. Then visualize data is that we need to see the data in analytics form. Then we optimize data means that sometimes it's not good enough, it's not fast enough. You can push the pipeline and make it fast or just make it happen. So then everything will be useful. Then I do the experiment again before we do analytics. We have to do a lot of experiment to ensure that the time is fast. And also, there are also different steps with read, process, update, visualize. So each step corresponds to this execution time. So that instead of a lot of people talk about MapReduce, but MapReduce, what is it? Then we have to divide it into read, process, update, and visualize. So that in every step, we then take the time as the measurement. Then there are also standard deviation to help us. Sometimes if there's a very large standard deviation, it means that something is wrong. So that instead of looking at the entire MapReduce, we then check which one goes wrong. So this is a better approach. So similarly, things may be getting very complicated for visualization. Visualization easy, but to do visualization, then we have to further to get into it, because visualization means that we have to check the data before doing visualization. So there's an extra step called check. And then categorize. What does it mean? It means that I have collected all the data, but then I need to categorize them into 11 groups, like from the lowest to the highest. So then I have to check and then rank all of them into 11 groups in real time. And then after that, I give a color. So each 11 groups, like each 11 group, there is a color code. So if I go the lowest, I go the dark blue. And then if I go the highest, I go the red color. Things like that. And then after that, I then map it and visualize it and optimize it to accelerate. Just like you are driving with a manual car. Want to make it faster, you can push to gear 5 or gear 6. It's similar. So this is how I do. So I started with US, polar vortex. That started in 2014. So what does it mean? It means that at the time, USA was like as cold as to Antarctic side. It was so cold. Then when you went out, everywhere was all snow, covered by snow. So there was extreme weather. So extreme weather shows that, like some part of USA, you probably don't have to go to Canada, to see the northern light, because northern USA is almost as cold as like that. So, in order to understand it, we then have chosen 4 days, because to collect data for every day is a very manual process. And then there are also talks about smart data, which means that you only pick on the day with a very specific meaning. For instance, like a few days, Real Madrid versus Barcelona, you don't pick all the dates for all the football teams. You only pick the date of interest. So those 4 days are being collected, and then they have been analyzed again. So you can see the northern part is very affected, and then the South USA is so far so good. So the other 4 days, then you can see, within 1 second, it's still very cold. It's very unusual. Even in March, it's like as cold as in northern Canada. So the impact is immediate. And at the same time, you can see the UK, because UK in 2014 suffered the flood. So which means they had a very warm spring. So a warm spring means, in February, it's supposed to be very cold. We are supposed to see all the blue colors. Blue indicate coldness, but it's very unusual. In winter of UK, that looks like a hot spring, So that is why it's causing flood, because it's supposed to be snowing, but then instead it was raining. So similarly, you can use that. And then we use all this and optimize. It's like I want to move myself into the 6th gear. So I also have to do another test. Before I move to 6th gear, I want to measure, is it good, or should I do this? So then I also make comparison. So when I move to 6th gear, things are slightly better. Yeah, slightly better. So it's like here. Yeah, so then those things. So then it's very helpful for us to compare, because whatever we do, we have to compare with what other people have done in the past. So now, case study 3. I know that there are some audience from mainland China. You may notice something is missing here. It's not because of politics, it's because the data in China and Taiwan are completely separated and managed. So I do not have any interest in politics. I'm personally from Taiwan. So then in China, and that is before I came to this conference. So we one glance at 4 a.m. Why 4 a.m.? Because in order to test whether this country has been affected by global warming, the best thing is that you check the weather of the entire country, early in the morning, so that you can see that in some part of China it's very cold. Of course, the Tibet is very cold, and then Inner Mongolia very cold, and in the eastern coast is warm. So then how about Taiwan? Taiwan, that's in April. So it's very unusual to have nearly 28, 29 degrees Celsius. So there's a problem in Taiwan. It's called the hot island, because it's like almost 5 to 10 degrees Celsius above the temperature. So within one glance, you see the impact. And then I have explained the first part of the research question well. Then the second part of the world problem is about economy and finance, because we know the problems in 2008 and 9, a lot of European countries are still suffering. And then this is the architecture we talk about. We have lots of petabyte of data, terabyte of data, and then gigabyte of data. So that this shows all analytics, API libraries, software as a service, and these are the infrastructure as a service. And then some example, one of my single order paper, business intelligence service in the cloud, future generation computer system. This is the way people did it like 4 or 5 years ago. Like you can do exactly what a New York Stock Exchange do. So you can track the data, you can find the trading volume, and you can find the R-square value to see the risk. And then you can also make a trend. So based on this, and then I make a trend. And then what does it mean? It means that my prediction is always 15 minutes ahead. So then based on this, so my journal article is like I got 3 chains. So I track the volatility and prediction. And then I find the middle value. So I'm always 15 minutes ahead. And then most of the time, with more than 95% of accuracy. So then, is it good enough? Because in our world, we always move forward. So my latest approach, obviously, that's not good enough. Why? Why is not good enough? Things like that, with a sudden speculation, it's not good enough. So now, what I do is that I calculate the highest and lowest value, so that whatever you do, whether you speculate, it's always somewhere in the middle, in a red color, so that the Microsoft stock analysis is always being tracked by the red regions. So they are always in the middle. But at the same time, it's not just for Microsoft. We can then do more stock analysis, such as Facebook. Facebook is on the way up, and then Apple. So these red colors means what? The differences between the highest and the lowest value per day. So whatever you do, you are always inside. My approach now is that I don't care what you do, but I got the highest and lowest, and I got 2 very tight rope. I always tie you up. So whatever you do, you are always within my management and control. So that's and now, is it good enough? Probably not. What we can do is that now we want to zoom it. So why? Because we want to see, there are some speculation, like why all of a sudden it's down? Why all of a sudden it's up? Then we need to know, oh, so regions like that means that there's some unexpected human activities, just like some of the audience just leave, which are of my expectation. But then whatever they do, then I can always make a prediction on it. So whatever value you fall into, you are always within my expectation. But we can also do the oil prices, because oil prices is a good example. Like especially in year 2008, then you have very high values, and then now the values are back to normal, and then the values are now down, but then slightly up due to the speculation. So the problems in finance and economics is also an issue. But at the same time, we need to study the populations in different countries. So in mainland China, they have different provinces. So to understand the population in each province or state, so that the government can better allocate resources, so that places with more population, you get more resources, and then you can then better manage as a government. So that with different provinces, then you will be able to see, like different provinces and direct cities, then they can have a different type of population. So within 1 second, you know how many people are there. So then, how about the economic situation in the USA? In the USA, we have different type of administrative region, but then, the economy of USA always affect the world. So then it's also important to understand. So per capita income means that this is the average value for the people in the administrative region, because it's impossible to get the value of individual salary. So the best approach you collect as a collective group, although there can be certain discrepancies and discussions for the measurement, but this is the best approach so far, because you cannot get everyone's salary, but you can collectively get everyone per capita income. And the data is open. You can download from US government or even Wikipedia. But then Wikipedia is just text. It's not good enough. We need to know where. So, near the Hollywood and those rich people's area, you see there are a lot of good income, but then there are places like that. If you have been to California, you can see a lot of people are begging for money, and then as a governor, do we need to do something? So now, the question is, if let's say there are some poor state, and why they are rich, should I move some resources here, or should I ask people here to get jobs, to get on with life? So this is it's already beyond the question about analytics. It's about decision making. What should we do next? When we have the result, what should we do next? So then, similarly, Massachusetts, we have a lot of smart people in Harvard and MIT. So, there are other people with very high capital. So they have a very high income value. And then those live along the coastal regions. They have also very high values. But at the same time, those live inside or inner land. It's like there's a huge divide between the rich and the poor. So as a governor, what should you do? Should we encourage people to get more jobs? Or should we encourage people to move there? Or should we encourage some housing development to be done here? Now the question is back to the government, the decision makers. What should we do when we have all the results? It's not just like knowing it, but then we need to do something about this. And then compared to other states, the Massachusetts seems to be better because it's more well distributed. But then the Washington state, as you can see, there's also a huge divide, the rich and the poor. The rich seem to live along the coast. As you see, if you live in an island, usually in USA, you are pretty well off. It's not the case, but collectively, you are pretty well off. You may have your own boats, things like that. And people live inland because, some part of USA, you can't walk at night. It's too dangerous, even as men, even as a group of men. It's too dangerous to walk there, and people may have a gun, things like that. But it doesn't mean, when we know this, what should we do? That is the question. And then, similarly, we are based in Europe. So after financial crisis, this is the GDP. Now, we can use GDP as an example. So what does this mean? This means that Germany, followed by Britain, then followed by France. Of course, common sense. But then, the impact of Britain leaving EU, this is a deep implication. When the GDP values of such a big player is gone, and then, Italy and Spain, although GDPs are fine, but government debt is also another issue. So, but without looking at government debt, just looking at GDP alone, you can have a sense that this is how the economic situation in Europe, and the GDP value, the entire Europe is not even equal to mainland China. That situation can be very difficult for some country and a lot of people. So as the governor or as the decision maker in Europe, what should we do? How can we create more job opportunity? How can we stimulate economy? It's like those results are beyond the level that they can offer to you. So similarly, we can look at other services. So I have another paper with Spanish researchers on smart cities, and also on the single order paper again on the other example and services. So then look at smart city because everyone is connected, and all the data, such as the transport data, such as the human activity data, can be all collected. So data can be collected and then in different contexts, and then it's going to create knowledge. So knowledge with different type of management, and then it's going to create values for different services. So then this is the architecture for smart city. But at the same time, all the rooms have all the sensors being installed so that your activities, such as when do you log into the internet, when do you log out the internet, and what sort of messages have you sent, because a lot of Wi-Fi here are probably not encrypted. So, if they're one, they can collect those type of data. So then there are also some other systems that collect data of different types, such as how many customers come into the building, how many customers leave. It's just like the data is live, and they can capture a lot of this. And then we can then send to the decision maker, if we know this information, what should we do? So smart city can also be used in the railway systems, so that in different parts of Spain, there are some other sensors being installed, so that all the human activities can be recorded. And the human activities means that how many passengers do you have every day. So then you can look at this pattern. The pattern looks like we can cluster everything into 6 groups, so into 7 groups, so that there are a lot of people taking the train at those particular regions. Then as the mayor, so what can we do? Can we provide more services during the weekend, or should we have more trains on some particular areas? And then we can then cross-compare, different regions, how many passengers are in and out. So then smart city can also do the measurement of the temperature at different parts of Spain, so that you can then collect them, and then you can also cross-compare, so that you can get a similar pattern. So similarly, for the world, we have a lot of natural disasters. So sometimes it's very difficult to understand why the natural disaster happened. So those from mainland China, if you have been to Beijing, the quality of air is very poor, because in the past, we talk about the sandstorm, but now they talk about the toxic smoke. So now, let's say we focus on sandstorm simulation. So sandstorm was created because of deforestation. It means that a lot of trees are being cut, and then in the past, a lot of villages disappear. They become skyscrapers. So it means that the land become hotter and drier than usual, so that it creates more sandstorm from inner Mongolia or outer Mongolia region. So now the deforestation took place more inland. So then we have to take those simulations, so they help us to understand, how it looks like. So this means that, with a different scale, we know that the impact can be huge, so that we can then understand how it looks like. And of course, we will have to do something more in order not to make the land too dry. But at the same time, seismic simulation is to get an earthquake simulation. Why is it important? Because the earthquake in Nepal has made lots of people suffering from injury and death. So we do not like that to happen. So if we have some application that can warn us the likelihood for the next earthquake, even the 5 to 10 minutes information, they will help us to be able to escape. So, information like that will be extremely helpful so that we can then even develop with mobile app developers to tell us what should be the next thing to do. So that similarly, tsunami simulations will be the one that will help us. So tsunami can also be moved forward at a speed of 100 miles an hour so that everything can be engulfed. So I'm about to finish. Do not worry. It's not going to make any difference. Okay, so tsunami simulations will then understand, the powerfulness of the tsunami, is equivalent to 100 bombs and so. So, our world has a lot of issues. But now, would there be anything that help us to understand, yes, modern EIS, modern enterprise information system, to help us to understand the principles and the reasons behind, So the world, is it enough? If we look at a James Bond movie, you say it's enough, but actually, is it? Let's look at this again. Who say it's not enough? We have a lot of issues, and human beings tend to know, it just happened. But then, what are the reasons behind? What caused the real problem? So weather studies help us to understand that a lot of these problems are caused by our human activities. But then the finance and economics are purely the certain speculations that are caused by certain people. So then we need to know more about the world. So because there are a lot of issues, so today I have only focused on weather studies and economic and finance. So these are the two areas they have focused. So that in summary, the contributions is that it can provide a better, faster, and easier to use service because all the services going to be easy to understand and use. And then we can also interplay between different technologies, between cloud computing, Internet of Things, and big data. And at the same time, we can be successful on this so that we can do a better thing. So then, if we have the opportunity, we should work together with the journal. So I work with a different type of journal. So I have a deep knowledge about this. So if you're interested, you can send to my Gmail. Thank you very much. Thank you.
Okay, thank you very much.